So thanks, Julie. So I'm going to be talking about how we at the Times have built a user-friendly developer platform. So I'm Dave Grizzanti. I'm a principal engineer at the Times. I've been there for about 2.5 years, which is most of the time that we've been working on this platform. Today I'm going to talk through the journey that we've sort of gone on. Most of it's about the platform, how we're using GitHub at the center of that, and I'm going to wrap up a little bit talking about product management for folks who are interested. So for folks who are not familiar with the Times, our mission is simple. We seek the truth and help people understand the world. And we're doing that by building the essential subscription bundle for every curious person who seeks to understand and engage with the world. Most folks are probably familiar with our news product. I think that that's, the paper's over 100 years old. That's what it was founded on. But in the last, 10 or so years, the company has really expanded, and this is what the bundle is about. So from games like Wordle, which I'm sure a lot of people are familiar with, but even to some new games that we've been working on, like Connections and Strands, and going back all the way to the crossword, which I know has a loyal fan base. We also have a thriving cooking product, and then audio is another new area we're investing in, and then also sub-brands, such as Wirecutter, which the Times acquired in 2016, and also The Athletic, which is a sports journalistic paper that we acquired a few years ago. So all these things sort of make up, where we're looking for the future and how we're building more digital products. So this video that's going to play behind me is an example of some of the interactive news stories that we build at the Times, that the newsroom works on with engineers to build. So this shows a map using Google Earth, combining things like text and images and video to really tell this interactive story. And our goal on the platform team I'm on is to sort of build a platform to enable the newsroom and engineers to really build things like this without having to worry about what cloud platform to use and how to monitor, how to observe, how to deploy it. We want them to focus on building these stories and responding very quickly when things like this happen. They want to get these news stories out as quick as possible whenever there's breaking news. So to do a quick agenda, I'm going to go over the developer platform, some of the architecture behind the platform, and then I'm going to focus on platform as product, how we're sort of trying to cross the chasm with our internal users, and wrap up with some lessons learned. So for folks who are not familiar about what is an IDP, we're really referring to that as an internal developer platform. Some folks use the term IDP to mean internal developer portal. I'm not going to talk too much about portals today. I'm going to talk mostly about the platform. And the goal here is for our platform team to build golden paths that enable self-service workflows. And we're really focusing on a few things within this IDP. So application configuration management, infrastructure orchestration, environment management, deployment management, and role-based access control. And all of these things sort of make up the core workflows and core tooling that we're looking to include in our platform. And at the Times, the department that I'm in is called Delivery Engineering, and we're building this shared platform that's designed to create a set of tools and capabilities that any developer at the Times can use to accelerate their work. And this aligns with our enterprise goal of using technology and data to propel our growth. So this is a very simplified diagram of what an application developer's sort of core responsibility is, right? They want to develop. But in reality, a lot of their lives look like this, right? They're responsible for a lot more things than just developing software. They need to worry about containerization, which includes, where to store their images, how to build them, how to provision those images. They may be writing some infrastructure as code with Terraform or something else like that. Configuration management, orchestration, build, test, deploy, so what CI/CD tools to use, where to store their artifacts, what CI/CD tools to use, how to route traffic to their applications after they build and deploy them, how to worry about DDoS and web application firewalls, network policies, all of that. And then after that, how do they monitor it? The sort of observability space has grown a lot in the last 10 years, and there's a lot of tool choices there, whether it's where to store it, what tooling to integrate into your application on how to monitor it. So we want to sort of abstract as much of that as possible, sort of against the sort of shift left methodology, and make developers responsible for fewer things and let them focus on developing. From the perspective of what I've seen in the past at teams, is a lot of larger companies, the running of whatever platform you're using is sort of left up to the feature teams. Maybe they use a cloud provider and run Kubernetes there. Maybe they build Kubernetes themselves on bare metal. Maybe it's some mix of of the two, and they sort of have DevOps engineers sort of embedded, worrying about these things. And we're trying to sort of remove that so that the ideal use case is that we run a set of shared clusters that the teams can sort of use and not have to worry about operating them themselves. So we have shared dev, stage, and production clusters. And we're doing that by creating this sort of workflow for people, which I'm going to walk through now. So we have engineers sort of on the left and users on the right. So the first use case is how do they create a new application, or how do they get onboarded to this platform? And the idea here is to create something simple that they can use to get started. The next is some source control, which in our case is GitHub. The next is a CI/CD platform, so testing, building, and deploying. Next is a runtime, which we'll talk a little bit more about, but in our case is Kubernetes. And then some cloud provider where they can run everything that may not be Kubernetes. So any managed services that they need, databases, those sorts of things. And then lastly is ingress. So how do they route traffic to their application? How do they secure it? How do they deal with authentication? How do they deal with caching? And then across all of this is really observability. How do they monitor their application so that they know when it breaks or what the health is? And this sort of represents the workflow and components that we're building for our developers. So I'm going to walk through the create onboard step and how we built that, and also how we're using sort of GitHub at the center. So our goal is to allow developers to build fully functional services running in production on day 0 in under 10 minutes. This is a pretty lofty goal. We're not 100% there yet in terms of it being fully automated. There are some gates in place that our security team has to check off before people can run something in production. But if they were to catch that in the 10-minute window, everything else is automated for them to get the app up and running without them needing to do anything other than fill out a simple form, which I'll talk through later. So this template engine that we've built includes a bunch of capabilities that are shown on the left, and then on the right-hand side talks about what the user provides. So really, the template engine gives them source control setup, a source code starter kit. So we have a few languages that we support that gives them a template to start from, observability tooling, secrets integration, containerization, the build, test, and deploy pipelines, Kubernetes manifests, and also routing configuration. So all that they really have to worry about is their application logic, what services they're sort of building, and any kind of configuration that they might need to integrate with sort of the included capabilities. So all of that included capabilities is stored in a GitHub repository that we build for them. Includes all of that stuff as code. I'll walk through a little bit what each of those mean, but we're using sort of GitHub at the center. So the observability tooling is all using OpenTelemetry. We use Datadog as our sort of provider, or everything gets sent. Secrets integration is using Vault. Containerization is using Docker. The build and test pipeline is, we're not using GitHub Actions, unfortunately. We are using a tool called Drone. If folks are familiar with that. Was acquired by Harness a few years ago. We're still using sort of the open source version of Drone. And then a tool called Argo CD, which is responsible for the Kubernetes deployments. The Kubernetes manifests are using a combination of Kustomize and Helm, which I won't get into that too much, but if you're curious, I can chat with folks more about that later. That's in their GitHub repo, gives them all the YAML that they need for their application to be deployed. And we've sort of tried to package as much of it away into a Helm chart as we can. That's versioned and controlled externally, so all they really see is a values file and the ability to sort of write some customize if they need to make patches or something. So the workflow that we've built provides a form that teams can go to, that they fill out some simple stuff, name of their app, what team they're on to match the GitHub team, what tenant in our runtime that they need, a Slack channel, and they click go, and we store their answers as a serialized JSON in a GitHub repo. That kicks off another workflow in our Drone tool that basically builds out the scaffolding that they need. So the scaffolding includes their GitHub repo with all the stuff I mentioned on the earlier slide, integration into Vault for the secrets management, and then also everything needed on the Argo side to set up their project and their CRDs that are needed in Kubernetes to deploy their app, and then Argo will deploy it. So this whole process takes a few minutes, If that security check I mentioned earlier is done, then they can see their app running in dev within 5-10 minutes. Usually it takes a few hours for the security team to sort of check that, but once that's done, the app is up and running in dev. And then they can sort of work on it and promote it through the other environments and stage in production. So within that workflow, one other thing we've sort of introduced after the app is running is GitHub Copilot. It's sort of new for folks internally, which I'm sure it is for a lot of people. So we started a trial earlier this year to sort of get folks up and running quicker, either with their code or even interfacing with our platform to help them write Kubernetes YAML or Terraform. So we started off in January with about 25% daily engagement. That's increased to 30 as of August. And from a suggestions accepted metric, which is really, I think, what we're looking at more than daily engagement, has increased about 8% since we started in January. So we're seeing, positive growth with the use of Copilot day to day, accepted suggestions along with Copilot chat. So the platform runtime itself has a few pieces. So I'll focus first on sort of the cloud architecture. So one thing we decided to do is keep all of the Kubernetes runtime pieces sort of within our control in our own accounts, and then give teams their own cloud accounts so that they could manage their own managed services, databases, experiment as needed in sort of a prod and non-prod account. And the idea here is, we gave them the ability to have their own accounts, to have control over that, and we just link them back to our shared clusters through some routing policies. And this gives them the ability to play around as needed, keeps their accounts isolated, and also it helps with cost control, because we can see per AWS account how much they're spending. That's responsible for them since it's their sort of running pieces. And then the other sort of dilemma we had to kind of work through is whether for Kubernetes, whether we wanted to provide multi-single tenant clusters, so essentially a set of clusters per team or per org, or if we wanted to build a single multi-tenant clusters. So one big dev cluster, one big stage, one big prod, that sort of thing. And the idea here is, we had to sort of weigh the trade-offs of the overhead of managing all these clusters for individual teams, or dealing with, sort of noisy neighbor problems and other things with having these sort of shared clusters. And our design considerations we went through were a few things. One was sort of network isolation. It's sort of easier if everybody's in the same cluster versus everybody being in separate clusters and having to manage those policies. The next was role-based access control. So if they're all in a single cluster, how do we make sure that they don't step on each other's toes? We give folks access to only their tenants and not others. Operational agility just really refers to the networking policies that would be in place across the clusters depending on which method we chose. The next is policy-driven security, and that's just looking at how are we managing security policies across these clusters. And last is resource management, and this deals with just managing the resources from shared versus non-shared. And I think from the shared cluster perspective, we can sort of provision fewer instances, especially as we scale down in the evening or scale up during the day. So these are sort of the things that we looked at as we considered the clusters. We ultimately chose to go with the multi-tenant architecture. So I showed a picture earlier that showed sort of dev, stage, and prod, and this is our approach. So we've got sort of the team accounts I mentioned in cloud that they can control their own resources, and those are connected back to these multi-tenant, multi-region clusters. So clusters in multiple regions, but a shared cluster for dev, shared cluster for stage, and shared cluster for prod. And the way we sort of got around some of the security policies is we don't give tenants access to create namespaces or have any sort of cluster-wide admin permissions in Kubernetes. We created a set of operators that run on top of the cluster that provide sort of our own custom resources and primitives that let teams interact with the cluster to do what they need. So if they want a new namespace, they can do that, but they have to go through our operator that creates sort of a team space for them, and that gives them a set of security policies and firewall rules and such to know what which tenants they can talk to. And all of that is controlled through automation that we built with Terraform that lives in a GitHub repository someplace. So if you need a new tenant, you open a PR that says, here's the new tenant I need. The automation will run and sort of create that. So we don't give teams any direct access to the cluster outside of their individual namespace. So next I want to talk a little bit about continuous delivery. So I mentioned Argo CD earlier. So we are trying to move teams more to this idea of using GitOps as a deployment method. I think teams internally were sort of used to the approach of using drone or Jenkins in the few years ago, where they would write a lot of logic, whether it was in YAML and drone or in Jenkins, to do deployment, whatever unique way they needed. So if they wanted more advanced strategies like blue, green, or canary, every team sort of did it differently. And we were trying to move teams more to a single tool so that we could sort of standardize how our deployments worked. And this is where sort of Argo came in. So for folks who aren't familiar with GitOps, GitOps is an operational framework based on DevOps practices like CI/CD and version control, which automates infrastructure and manages software deployment. So the idea is that what is deployed in your infrastructure is stored in Git. And in this way, it enables developers to store the desired state of their infrastructure and then use it to deploy. So instead of generating a bunch of YAML and drone and then deploying it and maybe the cluster getting out of sync later, the idea is that they can generate that, store it in Git, and Argo deals with keeping things up to date and in sync. And our goals with the continuous delivery platform that we were building is to centralize CD software delivery and sort of pave the way for some of those advanced deployment capabilities that I mentioned before without teams needing to write unique rules. And this provides teams with more confidence to deliver software more efficiently, and we can offer predefined workflows as part of that templating tool I mentioned before, so teams get some of these things out of the box without having to say 6 months after they deploy their app, I want blue-green. It's just a checkbox that they can pick on the workflow. And this helps them adopt common workflows, and if we want to move to a new tool in the future, now that everyone's sort of on the same processes, it makes that process a little bit easier to migrate. I mentioned we picked Argo, and the way that our sort of Argo architecture works is that we have sort of a hub and spoke model. We've got a control plane cluster that manages all of the environments, dev, stage, and prod, and then separate testing clusters for dev and stage, and then all of the Argo projects, all of the deployment for Argo CD, and all of the applications are all also stored in GitHub. So we're sort of using GitOps to deploy Argo, in addition to the teams using sort of a GitOps approach with Argo to deploy their apps. So it's a little cyclical in that way, but the whole thing is sort of using these GitOps practices. So let me shift gears a little bit and talk a little bit about how we're approaching this, building our platform sort of as a product. First I want to talk a little bit about platform as product and how product thinking can help organizations build and evolve their platforms. So first I want to show this quote. This is from the ThoughtWorks 2021 Technology Radar. Then ThoughtWorks was sort of saying that they continue to see platform engineering product teams as a sensible default, with key insight being that they're just another product team, albeit one focused on internal platform customers. So this is really saying that even though you're an internal team building something for internal users, it's still a product. You should treat your users like users that are paying for your product to use, and engage with them in the same way. And in our case, we really wanted to engage with our product management team and see where they could help us build a better product for our users. And in our case, we're lucky because we have a few product folks embedded with us in our department. They're not sort of a separate team or a separate org that we have to manage. We have product managers and a leader sort of embedded with us. So if you're not familiar with product management, it sort of sits at the center of technology, business, and user needs. And I think in the scope of building customer-facing products, this has been around for a long time, but maybe on the platform engineering and internal user space, it's a little new. To make this process more concrete, what I'm going to do is I'm going to walk through sort of our journey from back in 2021 to now, and how we sort of built an initial MVP, engaged with users, and got to the point where we considered the product sort of GA or ready for sort of general availability. So we started off with discovery, and that was back in 2021. So this was really mapping the opportunity space. So we conducted user research across our tech org to understand the current needs and pain points of engineers at the times. And then we synthesized this feedback around some core domains for our infrastructure and product teams so that we could understand larger patterns and determine where and how more platform centralization could help users and leverage for the business. And so those core areas that we did the discovery on were CI/CD, observability, traffic and routing, runtime, and reliability. And based on the user research and looking at the diagram, this was really illustrative of the themes we discovered across the domains. There were discrepancies discovered in some of the user discovery, and the signals were that we were dealing with multiple types of personas across the org. Some folks felt that more standardization was better, but some people really wanted more autonomy to make decisions in some of these areas than others. So this sort of helped us learn where some of the gaps were in our initial thinking when we were building the product, and where we should focus as we sort of tried to move towards that MVP. So once we felt confident in the areas of opportunity, we aligned on what the first MVP of the product would be. And we used the opportunity we had coming up, which is sort of a hack week, hackathon thing that happens once a year that we call Maker Week. And the idea was to take the thinnest slice of the platform that we could for the customers in a low-stakes setting. So the idea and the opportunity we had with Maker Week was, we know that a lot of people are going to build brand new apps during this week, because they're sort of like setting aside their day jobs, and they want to get started really quickly without having to worry about, what tools should I use to deploy? I need access to this environment. How do I get started with this? So we use this opportunity to sort of validate our North Star of enabling engineers to start iterating on the ideas quickly. And then at the end, we figured out, how can we sort of incentivize feedback so people don't forget to let us know what they liked, what they didn't like. So in our case, we sort of decided to give out some gift cards as part of the survey, which encouraged people to fill it out because they could win a gift card. But we also got a lot of feedback throughout the process. And I forget how many apps we saw during that week, but it was in the 25 to 30 range as people were starting to just iterate on ideas. In some of the areas, that quick iteration really makes a big difference, not just for Maker Week, but also for things that could go to production quick. So I know, for instance, our games team is really interested in building new and exciting games, and we want them to sort of worry less about how to get these things deployed. So for them, they could build a couple apps a couple new games during Maker Week, try them out internally with employees and see what might stick. So after that MVP, we looked forward to our GA launch in 2023. This is back in the spring of last year. And we wanted to see, okay, so based on what we learned during Maker Week in this initial MVP, what features do we really need to focus on, and what do we need to build to get to sort of our general availability point. And the graph on the left represents the diffusion of innovation theory. It explains how, over time, an idea or product gains momentum and spreads through a specific population or social system. So as a product team, really the first goal is to figure out where in your organization the innovators and early adopters are, and who would be willing to engage in a new offering. And the idea here is, as we found, there are people inside the org that are sort of excited about trying something new, trying new technology, and aren't afraid to sort of be early users and find out where the cracks are and sort of report them. But there are other people who aren't interested in that. They're not interested in trying things. They want to sort of keep their life the same day to day and just work on product features. So really our goal was to build a coalition of the willing, find a few teams or individuals that are excited about what a developer platform could do for them and how the platform could help them deliver on the goals. Don't try to reach everybody all at once. Find those early adopters and sort of champions, as we call them internally. So in many ways, we realized that our platform was competing with a lot of tools that were people that were already used to using things like serverless technologies with no YAML, like we were offering Kubernetes. And that's a big thing to compete with, especially since we're sort of a small platform team. So how do we offer our users value that they can't easily find elsewhere? So, we had to regularly listen to prospective customers, and when they brought up things that may be critical, don't take them personally. Just think about what our platform can offer uniquely for our internal users, that something that they can't find out in the public may offer them. So as we're sort of moving through the MVP, getting to GA, and supporting more users, we had to figure out how to manage our spread of feedback. So we were listening to our users through various channels, whether that's Slack or meeting with folks on Hangouts or surveys or GitHub issues. And often the best source of information, honestly, was Slack feedback, but it's very raw and unfiltered, and we had to sort of parse it. And oftentimes it was a question asked, and then there'd be a thread with 40 responses that we're trying to read through. So we were taking all of this information in and trying to figure out how to manage it so that it didn't become overwhelming. So we sort of defined some core principles around the feedback. We needed to centralize it in a standardized way. We wanted to make it transparent for everyone in the platform team, so don't hide the feedback from the developers. And then it needed to be actionable via some synthesis. So what we ended up deciding on was this idea of a rainbow spreadsheet. So it's a simple method for visually identifying strong versus weak themes and qualitative data from user research. And it does that by placing individual observations in a spreadsheet and color coding them. So it sort of brings a quantitative layer of qualitative feedback by offering this heat map to understand the most common trends in the feedback. And the idea here is, we take a specific feedback, like in this case, it shows the create, and maybe the direct quote or a simplified version of the quote, and then put a color on individual teams that we may have heard that from, and then the more teams we hear from, and the more times we hear it, the counter goes up. And this sort of gives you a feel for, how often are we feeling people complaining about too much YAML or, too much complexity in the CD pipeline or whatever, instead of just the loudest, vocal minority of people who tend to complain about something that maybe is only individual to them. The next thing we also decided to do was come up with this capability maturity model. We often had folks internally refer to things as beta or alpha or POC, and we didn't have a shared language of what those things meant. So we decided to come up with this maturity model. It's largely based on Google's maturity model, at least the names. And the idea was, let's put the platform initially, but then also every component or feature that we work on through this maturity model. So the first phase is a POC. And the POC is really initial ideation and maybe something that we've built to sort of vet with users, but we don't let them necessarily use it yet. We may just kind of show it off to them, let us kind of work on it internally. And then the first phase where we really expose users to it is experimental. That's very early. We may have one or two teams playing with it, but things are most likely to change rapidly or break while they're using it, so just make them aware. The next thing is dev preview. This is we're most likely going to launch this. Maybe not as is, there may still be a few changes, but the idea is, if you're ready, we'll let anybody sort of opt into it if you're interested in using it. And then lastly is general availability. It's available for everybody. And the idea with many of these phases, at least for experimental and dev preview, we'd often put a new feature on that form that I talked about a while back when folks were filling out to bring a new app to dev or production. So at the bottom of the form, there may be a set of features that say, these features are in experimental, these features are in dev preview. If you're interested in opting into one of them, check this box and we'll provision that for you. One of the really successful features we saw here was this idea of building out environments when folks open pull requests. So a common feedback that we got was, I want to see my code running someplace when I open a pull request. So we weren't sure, is that going to blow up scale in the cluster? How much is this going to cost to run all these pull requests? So it's something that we sort of took through this maturity model to see what the feedback was before we launched it to everybody. But that was a very successful feature and is now something that's GA and that we offer to everybody. Okay, so we got through sort of our general availability. How do we scale now so that we can bring on any team that wants to run on the platform, and how do we get sort of the biggest users, or the biggest teams internally, like news and cooking and games, all onto our platform. So I want to go back to the diffusion of integration graph for a second and notice the notion of the chasm. So really the chasm represents this sort of shift in mindset from early adopters to early majority. And as I mentioned earlier, there's sort of a set of customers who are always going to be pessimistic about moving, and it's sort of moving past the people who might be excited about trying the product and really getting everybody on board without mandates. In our case, we weren't really mandating that folks move to this platform. We were trying to entice them with all the features we were offering, and sort of the simplified model of, you have less operations to worry about, and the common workflows we're offering will enable you to focus more on the product and less on the day-to-day operations. So as we sort of shifted out of our mindset of GA, we were able to sort of mostly cross that chasm, I would say. We've probably got 70 to 80%, I think, of our use cases on our platform at this point, at least for things that are containerized and can run on Kubernetes. And for a lot of folks that are not on yet, it's really looking at use cases that might be keeping them from moving and finding ways to sort of entice them to move or work with them to sort of do a migration over to the platform. So one thing to think about as you're sort of doing this is make sure you're rooting early architecture decisions for your platform within the context of your company's business needs and the culture of your tech org. One size doesn't fit all for everybody. Everybody's not going to be able to take the same approach. As a platform team, think about how you can scale confidence and trust in your platform. When you're doing those surveys, what are people really worried about? Is it, sort of efficiencies, stability? What are they worried about, and focus on those things. And highlight user success stories on the platform, invest in quality and operational excellence. We found doing sort of user interviews and taking pull quotes from them and highlighting them in sort of all hands really helped us when we were trying to get more folks on board. So let me just wrap up a little bit with lessons learned. So business and culture have a big impact on architecture. I mentioned rooting early architecture decisions for your platform within the context of the business needs. Platform as product, as I talked through, is about incorporating product thinking into how you build and evolve your platform. Again, the focus is on the users and the business. Really engage with your users and listen to them. And the last is, how do you sort of get across the chasm? And what worked well during the early adoption phase may not work when scaling out to the majority of your organization. So consider shifting your strategy, marketing, and investments to help scale and trust in the platform.